Number 103. So here I want to check for a GCF. So I have a 2 and a 6. 2 is a prime number, so it's the only thing that goes into it, and besides 1, right? And 6 is 2 times 3, so they definitely have a 2 in common. So I can bring a 2 down. I want to check the variables. They each have an a, so I picked the one with the smallest exponent, so a squared is part of the GCF. And they each have a y as well. So I want to pick the y with the smallest exponent, which is y to the first, right? The invisible 1 there. So 2a squared y is the GCF. So now I put the leftovers back inside, so I can divide these by 2a squared y. And so what will happen here is the 2's cancel out, and a cubed divided by a squared is just a. Y squared divided by y is just y. Okay, in the second term, negative 6 divided by 2 is negative 3. A squared divided by a squared cancels out. Y divided by y cancels out. So it's just ay minus 3. So here, that's not a difference of two squares, right? It is a difference, and there are two of them, but they're not perfect squares. This is not a perfect square, nor is this a perfect square. Okay, remember, for a variable expression to be perfect square, the exponents have to be even, and for a number to be a perfect square, it has to be another whole number squared, right? Like 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. So those are perfect squares: 1, 4, 9, 16, 25, 36, 49, and so on. So that means this is as far as we can go. So sometimes you only have one step, right? Or sometimes you might even not even have any steps. If you don't have any steps and it can't be factored, you can just say cannot factor, or you can just rewrite the original or box up the original. Any of those will be full credit, okay? On the assignment, it's you turn it in digitally online. So if I ask for the first step and the second step, if there's no other step, you can just rewrite the step you had before if it can't be factored more, and you'll get full credit that way, okay? All right, number 105. So here we have 4 terms: 1, 2, 3, 4. So this is maybe a grouping situation, right? And so remember that sometimes you might have to rearrange things to get them to match up, right? Like here they're arranged okay because I can factor out a b. Let's see if that'll work. If I factor out a b, I'll get a plus 2w. Here I can factor out a negative 4 and w, right? They both have a w, so I picked the one with the smallest exponent. So I can factor out a negative 4w, and that will give me positive a plus 2w. So that makes sense, right? All right, and so now we realize that, oh, this is in common with this, so we can bring that to the front, a plus 2w. And then our leftovers are going to go back inside. So the leftovers in this case are b minus 4w. All right, and that's as far as we can go. Okay, so here's the first step, second step, and then neither of these are factorable, right? They're not difference of squares. There's only 2 terms, so it can't be a perfect square trinomial, nor can we do grouping with it. So so that's as far as we can go on that one. All right, and finally I want to show you 109. So here's one where we have a common factor. They're kind of it's kind of like grouping, but they're starting us out a step ahead. So we can factor this common factor out, and then our leftovers are 2x. Right, so I'm going to put a 2x back inside, and then an invisible 1 here, right? So a minus 1. So 2x minus 1. Okay, and then this is completely factored. 2x minus 1, 2x and 1, neither one, or 1 is a perfect square, but 2x is not a perfect square. So it's not a difference of 2 squares. So we can't factor that. But this we can, right? That is a difference of 2 squares. 4x squared is a perfect square, and 1 is a perfect square. It's a difference. There's 2 of them, so we're in good shape to factor that out. So I'm going to bring down the 2x minus 1, right? That's just going to come down because it can't be factored anymore. Take the square root of 4x squared, and that gets me 2x. So I'm going to put 2x here, 2x here. Take the square root of 1, and that's going to be in the second position in each of those binomials. And then since it's a difference of 2 squares, we're going to put a plus and a minus, and that's it. Okay. Now I can also rewrite this. This will be okay for full credit, but you can also rewrite it as 2x minus 1 squared, right? Since there's 2 of these, we can use our exponent properties and actually add the 1 plus 1 and get 2, right? So we can actually rewrite that as 2x minus 1 quantity squared.